Hello, grade nines. Today we're going to talk about our last exponent law of this unit before we start combining them all together. And that exponent law is the zero exponent. Now, I know I wasn't there for your activity the other day, so I do want to do a quick recap of that activity, kind of off to the side. Now, one of the kind of prime examples I wanted to talk about was x to the power 5 divided by x to the power 5. Now, there really should have been two things that hopefully you came up with as a group yesterday on how to tackle this. The first thing that we would have talked about is how to simplify fractions that look like this. And I'm making some up. I don't know what your exact examples were from yesterday. I don't quite remember. But here we go. Now, when you simplified these, all of these simplify to 1 because I have every single piece that makes up the whole. So I have one whole. And hopefully when you were trying to come up with a rule on how to simplify fractions that looked like this, we could say something along the lines of when the numerator and denominator are equal, the fraction simplifies to 1. Now, of course, as you did this yesterday, what you came up with as a rule might sound slightly different, and that's okay, right? Because there's different ways to phrase the same idea. But hopefully you came up with something similar to this. Now, this rule would in fact apply to this more complex fraction, x to the power 5 over x to the power 5, because the numerator and denominator are equal. They are identical to each other, okay? So this fraction will in fact simplify to 1. The next thing that I would have had you try and do is look at this and think about the exponent laws that we've already seen before. Specifically, we would be using the exponent law for division. Now, that exponent law said that when dividing powers with the same base, we can subtract the exponents and apply it to the original base. Again, that phrasing that I've talked about just right now doesn't have to be identical to what you thought about yesterday, but it should be somewhere on the lines of what we talked about. Now, I'm not I don't find this super necessary that you write everything down because it's just a summary of the activity that you talked about. But if we go back to this original question or this original example, this means I could actually simplify this fraction in one of two ways. Way number 1, I know it's going to be equal to 1 because the numerator and denominator are the same. Way number 2, I know that that's going to simplify to x to the power of 0 because I subtract my exponents, 5 minus 5, and apply it to the original base. Now, these two different ways of simplifying are for the exact same question. So all three of these things are equal. So 1 is equal to x to the power 5 divided by x to the power 5. But x to the power 5 divided by x to the power 5 is also equal to x to the power of 0, which means that x to the power of 0 is also equal to 1. Now, when we talk about this method of simplifying here, we will find out that no matter what we started off with, whether it be x to the power of 5 divided by x to the power of 5. Or maybe I start off with another example, 2 to the power of 7 over 2 to the power of 7. I can still simplify these in the same way. I could say, yeah, that just simplifies to 1. Or I could say, yeah, that simplifies to 2 to the power of 0. And those two things are equal to each other because it's two different ways to simplify the same example, which means the simplifications will be equal to each other. Now, since I could do this for every single example that I throw at you, the conclusion I was hoping you would get to in that activity is that whatever I have raised to the power of 0, any base raised to the power of 0 will be equal to 1. Okay, that was the goal. Whether you got there or not, that's okay. But hopefully we can kind of see where we were going with that yesterday and kind of understand that concept here today in this video. So, our summarized answer here, our summarized law, is that anything to the power of 0 will be equal to 1. Okay? Now remember, this 0 exponent, or any exponent, only applies to what's immediately next to it. So as long as that base is raised to the power of 0, then that power can be replaced by the number 1. And it doesn't matter what that base is. That base can be, a fraction, as long as that exponent of 0 is being applied to the whole thing. My answer will be 1. So, we are going to go through a couple of examples today, and we are going to solve them all. Now, spoiler alert, the answer to every single one of these isn't 1, because A, that would be very simple, and B, that's not the situation we have all of the time. Yes, sometimes the questions that we have the entire base be raised to the power of 0. But sometimes I see a 0 exponent as just a small component to a larger question. And that's what you might have seen in the last slide of the activity from the other day. So let's go through them. Let's talk about each of them individually and tackle them together. So for this first one, I have one single power. My base is 15, and it's raised to the exponent of 0. 15, or any base, to the power of 0 will be 1. So in this case, my simplified expression is just simply 1. When I take a look at B, I could think of B in one of two ways, and I'll talk about it in one of two ways. The most simplified way to look at this is that 0 exponent applies to the brackets because that's what's immediately next to it, which means my base is that whole thing. My base is x squared times y to the power of 12, which means that whole entire base raised to the power of 0 is just simply 1. But some of you might think of this and go, hey, isn't this just power to a power? The exponent law we did prior to this one, where I have a power raised to another exponent, and in that case, I multiply those exponents together. And technically, you would be right. So I would multiply and go, okay, that's x squared raised to the power of 0, so x to the power of 2 times 0, which is 0. And y to the power of 12 times 0, which is 0. Well, look at this. I just have two powers with the 0 exponent. This first one can be replaced with the number 1. And I multiply by the second one, which could also be replaced by the number 1. And 1 times 1 is 1. So no matter how we tackle this question, whether we look at it immediately and go, hey, that 0's exponent is applying to everything here, so I could just jump to the fact that my answer is 1, or I do it in the slightly longer way, where I distribute that exponent to everything in my brackets, and I multiply my exponents together to get my new exponents, I will still end up with the same final answer. I will say that this is the preferred method because It is quicker, it is more simplistic, it saves you a lot of grief, especially because I can give you a really, really, really complex question, and I'll make it up just to kind of show you. I can say x to the power of 4 times y to the power of 7 times 3 times x to the 17, y to the 32, all over, let's say 16x 7 y to the power of 4 all to the power of 3, but that whole entire thing to the power of 0. Yes, I could take the long way. Yes, I could simplify everything inside my big brackets. Yes, I can do all of that work. But if I notice that that whole entire thing is being raised to the power of 0, I can jump and go, hey, that's just 1. So even though the long way might still get you there, if I notice an exponent to the 0 is being applied to the whole entire thing, take the shortcut. Go right there, because anything to the power of 0 will equal 1. Okay, so those are my first 2 examples. The next 4 examples are a little bit more complex. Okay? When I take a look at example C, I don't actually immediately see anything that has a power or an exponent of 0. Okay? So I'm just going to treat it like I normally would. This looks like a division question or a division of powers. Now 10 and 2 do not have the same base. They cannot be written as the same base. So I divide it like I normally would. 10 divided by 2 is 5. Now x squared and x squared do have the same base. So I can do my division of powers by subtracting those exponents. So I will end up with x to the power of 0. And now I kind of see why this question snuck into the 0 exponent section, right? Because even though the 0 exponent wasn't obvious in my question, it shows up in a later step. Now notice that 0 only applies to what's immediately next to it, which is the x, which means when I replace that power with a 1, I am not replacing the 5, because I had 5 times x to the power of 0, which means I have 5 times 1, which means I just have 5. Okay. Next question. Very, very similar. I don't see any 0 exponents immediately, but I do have division, so I'm going to use my skills just as before. Now I notice x to the power of 9 is at the top, and x to the power of 9 is at the bottom, so I could use my quotient of power rule, which means I subtract the exponents, giving me x to the power of 0. But I notice that y squared has no other power with the same base to do anything with. Now this is very important. I'm about to write something wrong, and I don't want you to copy it down. Ready? I want you to think about why this might be wrong. Now I can't ask you because I'm not there with you in person, but notice in the question that y squared was in the denominator. It was underneath the fraction line. But if I write it here as multiplication, I'm changing the operation. Before I was dividing by y squared. When I rewrote it here incorrectly, I changed it to multiplication. I am not allowed to do that. I need to maintain the equality of each line. So I could change some things by simplifying it, but I can't change its value. So, since that y squared has nothing to simplify with, I keep it where it was originally. It was in the denominator originally, so I keep it in the denominator in my next step. Now I have x to the power of 0. We know anything to the power of 0 is 1. And that y squared I did nothing with. There is nothing further I could simplify at this point. So my final answer is 1 over y squared. Okay, 2 questions left. This one here, again, when I take a look at this one, I do have an exponent of 0 immediately. And when I look at what that 0 applies to, it applies to that large bracket which means it applies to this whole entire thing, which means that whole entire thing raised to the power of 0 is just 1. I don't have to do anything about simplifying the brackets because that whole set of brackets is being applied to 0 after, and I can just go straight to that end result. Okay, last one. In this last one, I do have a 0 exponent. When I take a look at a question like this, if I can simplify within the brackets, I'm going to do that first, because I'm always going to want to try and follow bedmass. So inside my brackets, I know that 7 to the power of 0 is 1. And I have x to the power of 4, which I cannot further simplify. Then all of that raised to the power of 3. Now, inside my brackets, I have 1 times x to the power of 4. But I know that when I multiply by 1, it doesn't do anything. It doesn't change my value. So I can actually just rewrite that as just x to the power of 4 to the power of 3. That multiplication with a 1 doesn't do anything. And now I have a power to a power. When I take a power and I raise it to a power, I multiply those exponents. So I get x to the power of 4 times 3, which is 12. And that is my final answer. Okay, long story short, in this section we talked about the 0 exponent. The 0 exponent, raising something to the power of 0, is always something that can be simplified to the number 1. Okay? When we go through these questions, sometimes the 0 exponent will be really obvious. I could see it right away in the question provided. But sometimes I might see it after I do some simplification. Okay? Either way, I want to be aware of when it pops up and what it can be replaced with. Lastly, just a reminder is that an exponent only applies to what's immediately next to it. So I do want to have that thought of what that 0 exponent is applying to, because it might be the whole entire thing, or it might be a small segment of the bigger question. So please just be mindful of that. Otherwise, that's it, and that's all. There's some practice that follows. Tackle that, and I will hopefully see you soon. Have a great day. Bye.